Thank you everyone for attending. My name is John Marlin. I'm a program manager at Microsoft, and here today with my buddy Jake here, we're going to talk to you about Storage Replica. On the agenda today, we're first going to talk about what is it? What is Storage Replica? We're going to talk a little bit about the differences in synchronous versus asynchronous. We're going to talk a little bit about some of the requirements and recommendations we have for Storage Replica, setting it up, and then show you some of the disaster recovery scenarios that you can configure with Storage Replica. So the first thing, what is it? First off, it is in-box replication. It comes in Windows. It is not an add-on, not anything else you have to pay for. It's in-box, ready to go. It is block level, volume-based replication. It's not a file level based replication. It is block level. You can do synchronous or asynchronous. We'll talk a little bit about that here after a while and as we go along. We also take advantage of all the SMB3 transports that are available. It is also flexible. Any Windows volume, any fixed disk storage, any storage fabric. We work with pretty much all of it. We work with SANS, we work with iSCSI, we work with SCSI, we work with SAS. Very flexible in what we can do. And lastly, management. It's ease of management. There's different ways of doing it. Failover cluster manager, if you're working inside of the same cluster, can use it. Windows PowerShell is always there. We've also added into Windows Admin Center an area for Storage Replica and setting it up, manipulating it, doing what we need to within Windows Admin Center. All three of these allows us to do what we can do and make things a lot easier for you. If you see here, here's what the storage stack looks like. You can see here's our source server, here's our destination server. As you can see, we're SR here in the green. Way down the storage stack, we're at block level. We don't care if it's NTFS. We don't care if it's REFS. Don't care if it's BitLockered. All these other filters that you may have, we're going to sit below it. Again, we are block level, not file system level. We don't deal with the file systems. So this allows us to take blocks, no matter what the drive is, no matter what the file system is, and move them between our source and destination servers. So now we want to talk about synchronous versus asynchronous, because there's always a question, which is it do I want? So let's kind of see how it works. For synchronous, we're going to write to the source and the destination at the same time. So what we do, here's our source server, here's our destination server, here's our application. Now, when we set up Storage Replica, we have a log drive. That log drive is what we're going to write to, replicate between the source and the server, and then actually write it to the data drives. So this is the step we're going to do. An application makes a call, it's going to do a write to the source server. What we're going to do now, as Jake shows you here, we're going to take that copy, we're going to take that block that was just written to the log file, take it over to the destination server, give it to the log file there. Once it's written, we'll go back to the source server, go back to the application and say, hey, it's already written, do whatever it is you need to do now. At that point, we also write our tertiary write to the actual data drives and write that actual data. Everything stays consistent. Everything is synchronous. We do not write anything to data drives until we ensure that it is in sync. Both logs are in sync. An application goes to do a save. We're going to take that save to the log file on both ones, replicate it over, send it back to the application to say, hey, it's saved. Go ahead. We do our tertiary writes to the data to show that it's saved. For asynchronous, we're always going to write to the source server first, ensuring everything is written to the source before we ever replicate anything over. So our same diagram here, source server, destination server, and application. Application goes to do a write. We're going to take that write it to the log of the source server. Once it's been written, send back to the application that, hey, it's written, move on, do whatever it is you need to do next. At that point, we will then replicate it over to the source or to the destination server and its log file. From there, we send back, says, hey, everything's okay, write our tertiary writes to the data. So we ensure everything is written. Everything is proper. Now, one of the things about asynchronous is RPO times. People want to be able to control their RPO times. As a default, we're going to keep it within 5 minutes. You can change this when you set up your partnership with Async RPO. Default is like 5 minutes, like I said. You can take it down to as little as 30 seconds if you want, depending on how much latency it is that you have. If we ever go over our RPO, we will log an event 1239 and let you know, hey, it's over. You can also see this information if you do a get-sr partnership. Now, one of the questions I have or have had is, can I change it after the fact? The answer is, unfortunately, no. This is only set when you initially create the partnership. If you want to change it, you have to break the partnership, recreate the partnership. Some of the requirements that we need for Storage Replica. We do need to be in the same Active Directory domain for the source and the domain, because we do use Kerberos for everything. We need a minimum 2 gig of RAM and 2 CPUs on each side, the source and the destination. For synchronous replication, you need to have less than 5 milliseconds for round trip. Otherwise, we will strongly recommend that you use asynchronous. A minimum 1 gig network, GPT disks. The thing about GPT disk, remember, or not GPT in particular, but disks in particular, same size, same attributes. Everything about it has to be the same. We're doing block level. We're not doing file level. So they need to be the same. Same resiliency, same interleaves, same block structure, same everything. We also have a few firewall ports. We do use SMB. We also use WSMAN for a lot of our connections. So those firewall ports need to be open. Some of the recommendations that we have is a 10 gig or higher network. There can be a lot, depending on the amount of data that has to get written across, there may be a lot that's done. So you probably should have a 10 gig or higher network. We've always recommended the log drive be faster than the data drive. In nowadays world, in the all flash systems, obviously that's not possible, but this was more recommendation back during SDD and HDD days. SDD, you wanted to be faster. You don't want a bottleneck on the log drive writing data. So it needs to be faster or the same. RDMA is also preferred as well. That way there's less CPU overhead for a lot of things that we're doing. Depending on how you are network WAN wise, RDMA may not be possible. Stretch clusters as an example, between multiple sites going over a WAN, you're not going to be able to set up RDMA. But on a local network, RDMA is definitely a recommendation to help speed things up. When you're setting up Storage Replica, so before you begin, we want you to do a test SR partnership. Testing the partnership will allow you to see how it's going to function. Are the drives the same? It's going to error if they're not. What kind of round trip latencies is it for the type of data that we're going to be sending across? How much data can you send across? There are many things about testing the partnership first that can possibly give you insight into possible problems in the future. Now, we do recommend that it be run for an extended period of time. You know, that could be anywhere from a couple hours to 8 hours to 10 hours to a full day. You know, we don't recommend something that's like 5 minutes long. You know, we want an extended period of time. Also, preferably running the type of load that you're going to be running. You know, if you're just simply copying files and moving files around, you know, it may look good from a test SR partnership, everything may pass, but if you're running SQL, that's a totally different IO load. So we want to ensure that you're testing it on the type of workload that you're going to be using so that we can see that we're going to function properly. Also, test SR partnership, test SR partnership, test SR partnership, test SR partnership. Test it out first. Head off any problems you're going to have before you even begin. Creating the partnership, there's two different ways of doing it. There's new SR partnership if you want to use PowerShell. For the async RPO I discussed a little previously, it has to be through partnership. It has to be through PowerShell. Windows Admin Center can set it up as we will show here in just a minute. And you can also do it from within Failover Cluster Manager if you are setting up within the same cluster. So here I have a stretch cluster that I'm going to have. 2 nodes each side, one in Seattle, one in Redmond. I go and look, here's my pool. I simply choose create. This is one of the things that makes it so much easier with Windows Admin Center. I select replicate volume between the sites. I want to replicate this volume. Say which direction it is. I can go from Seattle to Redmond or Redmond to Seattle based on the volume. I can choose asynchronous or synchronous. I choose what's the name of my volume. I can call it whatever I want. It will also call the other drives that it's going to create, and we'll see that. It's going to be a two-way mirror. It's all on SSD. What size is the drive that I'm going to be creating? Under the advanced, if you wanted to choose advanced, you don't have to. You can see here we've renamed the replication group by what you've called it. Here's my log size that I want to have. We're going to default at 40 now. I just set it for 10. There's other options here using the blocks already seeded, which there's no drive, so you can't do that. We can encrypt the replication traffic if you want, enable consistency groups if we need write ordering for things like SQL, as an example, and I simply hit create. At that point, what it's going to do is it's going to create all the drives for you. It's going to create the data drive on each side. It's going to create the log file on each side, and it's going to set up the replication. As you can see here, it's created my Seattle disks. It's created my log drive in Redmond. And you'll notice here you don't see the data disk for Redmond. We do hide that so that you do not have access to it. We don't want you to have access to it. But if I go and look through PowerShell and do a get-virtual disk, you can see here, Here's all my 4 drives. Everything is healthy. Everything is ready to go. If I look at it from within Storage Replica inside, you can see here's my partnership, and you can see it across the top that it's doing its initial syncs right now. Here's all my information about it. So only a few steps. I want to replicate. Which direction? What's the name of the drive? What's the size of the drive? That's all you really have to do. All the other defaults are there for you. Just simply hit create. And you're done. Easy, easy, easy is what we wanted to try and make it. Some of the disaster recovery scenario setups. We can do server to server. So we can do all sorts of disaster recovery scenarios server to server. It is only a single server to a single server at a volume level. Now, it's at a volume level. So if I had multiple volumes, say I had this one drive I wanted to go from building 5 to building 9, I set up an SR partnership for that particular volume. But there's a second volume in building 5. I want to go to building 22. I can set up a separate SR partnership for this other drive to replicate to building 22 if I wanted to. So you can get a little crazy, if you want to call that crazy. So you can do this on a per volume basis. It's not the entire server, it's a per volume. If you wanted to go cluster to cluster, that's fine. Same premise. It's all through PowerShell. It's all through Windows Admin Center. If I wanted to do a stretch, this is where we can actually run through Failover Cluster Manager. We've had this since Windows 2016. The key point about all of these is synchronous or asynchronous. You can do either one. However, server to server, cluster to cluster, there is no orchestration between the two. So if there is a failover, if you want to call it, you want to move from, say, this first one, building 5 to building 9. You just reverse the partnership and bring up your application, virtual machine, whatever it is that you're running. And at that point, everything is reversed. You're working off of building 9. But this is a manual process that you have to do. In a stretch scenario, it's a little different. If you do synchronous, synchronous is an automatic failover. It will automatically fail everything over. It will automatically bring everything up. If you are asynchronous, we are not going to bring everything up for you automatically. We'll move it over, say New York goes down, or you do a manual failover from New York to New Jersey. We'll do the failover, but we won't bring it up. We want you to decide when you want to bring it up, which is part of asynchronous, because part of the things that you have to consider is it in sync? And we're not going to automatically bring it up if it's not. With synchronous, it'll be in sync. So what it would look like is this. Here I have my stretch cluster. I have Seattle data, Seattle log, Redmond data, Redmond log. I am replicating from Seattle to Redmond. I have a virtual machine running, so you can see that it goes and it comes up. Here's the data drive that I am replicating. And my nodes, 2 in Seattle, 2 in Redmond. So everything's running in Seattle. I have a power failure. I have a flood. I have a tornado. Something happens in Seattle that causes the site to go down. So what we're going to do is we're going to automatically move everything over. See, my virtual machine is already running because it's still running from stuff. I have my Redmond data. It's starting to bring everything online. So I have my Seattle data resources online. All it's doing is pointing to the local drives there. My virtual machine is running. I'm up and running. Everything's good. This happens at 2 a.m. on a Saturday night, Sunday morning. Everything's done. Seattle comes back up. You'll notice that once it comes back up, it will only bring the replicated 2 volumes over back to Seattle. We're not going to fill over everything, the main production back to Seattle, because those drives over there need to get synchronized. Once everything is synchronized, you can manually move it back. If you want to try and move it back beforehand, if it's not synchronized, we will not allow the move. So here I go ahead and move it back to Seattle. Everything switches. So my data drives move back to Seattle. A note in Seattle. My replicating 2 drives move back to Redmond, and I move my virtual machine back. All automatically for you. So to wrap things up, we talked about what it is. It's flexible, several management options. It's inbox. We talked about sync or async. Sync being it writes to both sides at the same time. Async, it writes to the source first. Once it's complete, then it writes to the destination. Talked about a few of the requirements and recommendations, how to set it up, showed you how to set it up with Windows Admin Center, and then some of the disaster recovery scenarios that you can have. Server to server, cluster to cluster, or stretch cluster. Stretch HCI with the new Azure Stack HCI that's soon to be released. Thank you for watching. Jake thanks you as well. For any information, aka.ms/storage replica. If you have any other questions, please hit me up. Again, John Marlin, I own Storage Replica as a feature from the product group standpoint within Microsoft. Here's my Twitter account. I'm available email, I'm available Twitter. However you want to get a hold of me, I am always available. Anytime you want to discuss something, let me know. I can do whatever I can to help out. Thank you for attending. Jake here. He thanks you for watching, and have a good rest of the day.